Yeah. So in this question, we have a balloon which always remains spherical has a variable diameter. Okay, this one we discussed, Yes, sir.
Yeah.
We discussed.
Yeah.
Find rate of change of its volume with respect to x. So dv by dt. Okay. So okay, we'll respect to x now. X is what is the question? So direct actually. So this is a sphere, right? With diameter, variable diameter. Okay. So what is V? Volume is what? What is volume? 4 by 3.
Is 4/3 pi r cube.
So in this case, we take as 4 by 3 pi r. Yeah, this is what is D, diameter. Diameter is what? 2r. 2r is what?
Yeah.
3 by 2 times 2x plus 1. So that's going to be 3 by 4 times 2x plus 1. So this is what is diameter. So with respect to x he is saying, so that's what is with respect to x. So what we write is here dv by dx, dv by dx.
Yeah.
Okay, equal to what? 4 by 3 pi into 3r cube, 3r square into dr by dx. Yes, sir, with respect to x, 3r square dr by dx. So here also you write dr by dx. What is dr by dx? 3 by 4 times 2 into dx by dt. So 2 into dx by dx. Yeah, that is 2. That's it. With respect to x only, na? 2. So,
Yeah.
substitute. 3 cut. So 4 pi r square. What is r here? What is r? R is this.
Yeah.
You get answer in x only, na? Obviously, because your diameter is given in terms of x. So
Okay.
3 by 4 into 2x plus 1 whole square into dr by dx, that is 3 by 2. So you can cut off this one, 4 gets cut. 4 pi
Is it not cube? Isn't it supposed to... Okay, never mind. Yeah, okay. Yeah.
that cube only became square. So this is 9 by 16 into 2x plus 1 whole square into 3 by 2. Okay, this is 4 fourths. So whatever comes, the answer is
1 second, sir.
27 by 8. So dv by dx, which was asked, is 27 by 8 into 27 by 8 into 2x plus 1.
So let me just copy this down 1 second.
Right. All right, you can try. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. Okay, this is sand is pouring, sand is pouring. That means what? Sand is pouring like this. That means what? When sand is pouring to form a volume, actually is what is volume. Sand is what we measure in terms of volume, right? So that means what?
Yeah.
d by dt is given as 12 centimeter cube per second. The sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. So here this falling sand is forming a cone actually. This fall, so it's coming. See, you know that this is it is forming a cone like this. A cone actually. The cones are all sand particles is like a cone like this. It's a form cone like this, and this cone has in what kind of cone is it? Such a way height of the cone is always sixth of the radius of the base smaller. So this radius. This radius is there 6 times the height. This is what is the height of the cone. Yes, height.
Yeah.
So that means what, R equal to 6H also we can write this relation, right? So
Yeah.
is how fast is the height of the sand cone increasing? That means what, dH by dt is what? When the height is 4 centimeters, then h is 4 centimeters. Okay, when volume is given and height is asked, right, you have to take volume of the cone. What is the volume of the cone? Formula?
1/3 pi r square h.
Yes, 1 by 3 pi r square h.
Okay.
But you see, whenever you differentiate, here there should be only one variable. Here you have two variables, right?
Yeah.
So what you want is you want dH by dt. So R you don't need. So therefore remove R using this.
Okay.
So if you
Okay.
remove R by using this, okay, R you have to
Yeah.
replace with 6H whole square. So this is what is the thing here. 5 by 3 here. 6 square is 36 H cube. Volume is now there 12 pi H cube. That's it now. dV by dt is what is 12 pi times H cube is 3H square into dH by dt. Oh, that's it. Now dV by dt is what? That's it over. If you want, you can copy them.
Yes.
This 12 centimeters. 2 per second is this also 12 pi into 3 times h square. What is h here? When h is 4 centimeters. So when h is 4 centimeters, in h centimeters. So 4 square into dh by dt. Everything is substituted. Oh, then that's what is dh by dt. It's a small thing, small one. What is the small quantity? Change in small quantity. What is that? 1 by 16 threes. 48.
48 pi.
Yeah. So this is centimeter per second.
Yeah. Yes, sir. Got it.
Okay. So
So should we start the next exercise? We can finish this exercise first and then go back to those doubts.
increasing and decreasing. Increasing and decreasing. So function means if you draw, it's a curve. Okay. Function means what's a curve?
Yeah.
Yes, if you draw, you'll get some kind of, it's a straight curve. Anything is curve actually. Straight line is also curve.
Yeah.
Get a curve. So increasing and decreasing of the function. So by using application of differentiation, by that means what? By using differentiation, you can know whether the function is increasing or decreasing. So what does it mean? See now, let's draw a diagram like this. So now I'm drawing a diagram like this, like this, like this. Okay, it's constantly going like this, down, and it's going up like that. So as see, this is x-axis and this is y-axis. As x is increasing, you see y is 0 here, the y is here this much, y is this much, y is this much, y is this much. So let's take this is x1, x2, x3, x4. As x like this, as x is increasing, you are able to see y value is also
Increasing.
increasing. So this is called. So now if you go this side, as x is decreasing, this side y is also decreasing. The same thing you can say y is decreasing. This is negative, na? Swallow -2
Yeah.
number down, -4 like that down. So as x is decreasing, y is also decreasing. That means what you should always check from left to right as x is increasing, y is increasing. So this is called increasing function. Okay, increasing. But you know, more appropriately, what we should say, strictly increasing. You understand? So
Mm,
oh, strictly increasing. That means what? There is a function which is increasing. Understand?
okay.
So
Yeah.
this strictly another thing is there now, you know, this is like this first, and then this is like this, and then this is like this, going like this. So you understand? So
Yeah.
actually, if you see from here to here, if you see from till here, it was strictly increasing, you know. But here,
Yeah.
happened is all constant. It's not increasing or decreasing. It's all constant. Okay, and then again it is increasing.
Sir, you're not audible.
Are you able to hear now?
Sir, I can't hear you.
Are you?
Sir, sir, 1 second. 1 second. Sir, can you speak again?
Yeah, are you able to hear now?
Yeah, now I can hear you. Yes. Yeah.
What happened?
Sir, I don't know. It just suddenly I wasn't able to hear you. Yeah.
Okay, actually here internet is unstable because I'm on hotspot. There's no power actually. That's
Yes.
how. So
Yes.
I think okay. One thing I'll send a video on this increasing and decreasing function.
Yeah.
There's a video for on so my video
Sir,
is
I can hear you now.
yeah,
I can hear you.
okay. Yeah, okay. Lot of suffocation is also there for me. That is the reason I'm saying. Okay. So it's a close to yeah, anyway, this is so that means what you know you can use here just increase here, just you can say this is um increasing, just you can say increasing, you know. Or another word is
Yes.
which is not used monotonically.
Okay.
Monotonically increasing, or just you can say increasing, you can say. You understand? Because it's
So
not
what if it decreases?
what?
If it increases and then decreases, what will happen?
No, 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 wait a minute. This is what is increasing. You understand? This much. So it is
Yeah.
strictly increasing. You're able to understand this? Increasing. You're able to.
Yeah.
The next here you see this is now you have here like this. So like this it is. So what can you say about this? What can
Strictly decreasing.
very good, strictly decreasing. Done. So the next one, if I say this, so first it is like this, and then this is like this, and then this is like this, and then this is like this, and like this. What can you say about this? So first decrease, and then constant, and decrease, and constant, and then decreased. You know, that means what it is not
Yeah.
decreasing. So it is, you can say decreasing. That's it, you can say. Okay.
Okay.
So then next,
Right.
we'll take another one. So now here is a, so here A point is there, here B point is there. In this interval, we check like this. So like this it is.
Yeah.
What is this? In this interval, this is what only constant. It's not
Yeah.
this.
It's not
So what we
changing.
say is constant.
Constant function. Yes.
Constant. Good. Constant.
Okay. Right.